Okay, I've got this platform. It weighs 60 pound and supports a 240 pound at its header. So a total of 300 pounds is shown there. Okay. Basically, it's just got the one brace. It's drawn one in there, but then it removes it. So it's just got brace CE. What I want to do is I want to find the reactions at the hinges uh, and then and the force on um, yeah, the brace CE. Okay. And then it says hinge A does not exert any axial thrust. We'll talk about that one in a second. So I'm going to go ahead and start with my free body diagram. Okay. So I've got the 300, and then I'm going to have this force. I'm just going to call it F. I've got that strut force. That's the only force. Then I've got these hinges. Now, if you think about a hinge, you're not going to have any rotation, say, about the y-axis or the x-axis. However, if I do that, then it will be over-constrained in the sense that I'd have like 10 unknowns and only 6 equations to do it. So the way the book wants you to solve this is to essentially assume that there are no moments, which if you build it perfectly, then there wouldn't be any of these extra applied moments. Not the best assumption, but the assumption that we're going to do in the way that the book expects you to do it, as well as there's a homework problem that there's a similar question with that on it as well. So we will ignore those reaction moments and only deal with the force moments. So if I look at B, I'm going to have forces in all directions. Okay. So essentially, I'll have a BX, a BY, and a BZ. Now, A, this is where this sentence comes in. The hinge, oops, does not exert any axial thrust. What that's saying is there's no Z force at A, right? Along the axis of that rotation. So I only have a force in the Y direction and a force in the X direction, okay? So there's no axial thrust on this. So there's no Z component. There's just an AX and AY. And again, a lot of these assumptions are made just so that it is not statically indeterminate, which it would be otherwise, and would require more than what we know in statics to solve. So they're making those shortcuts because of that. Okay, not exactly the way Hinge works, but if we don't assume that, we can't solve it using what we know in statics. Okay, so now that I have my free body diagram, you see I have 6 unknowns, right? I've got 5 reactions and then that force at C there. So let's go ahead and write that force at C in Cartesian forms. All the other ones are pretty straightforward. So again, this will be my unknown force, and then I need to do the position vector over its magnitude. So I'm going to move 3I, 4J, and 2 in the K direction, as shown there. And I'm going to divide that. Unfortunately, this isn't one of those nice simple ones that we have sometimes. So I've got that. And what I get is these decimals. And I'll just go ahead and write them down so we have them. Okay. So 0.557 times F in the I plus 0.743 times F in the J plus 0.371 F in the K direction. So that gives me that force, okay? All the other forces are pretty straightforward, so I think I can go ahead and start writing my F equation, or yeah, equations. So in the X direction, I've got AX and BX, okay? Then I've got the 557 times F, okay? And that's all I've got in the X direction. In the Y direction, I'm gonna have AY and BY. I'm gonna have the 0.743 F, and then I've got my minus 300 acting straight down, okay? We'll set that equal to 0. Now we go to the Z. Now this time I only have BZ, right? There's no axial thrust, so there's no AZ. But I do also have my force, which will be 0.371 F equals 0. So I've got 6 equations, 3 unknowns. Obviously, this is not going to cut it. So what I'm going to do is I'm going to sum the moments. And I'm going to sum the moments about B because I've got the most unknowns at B. Okay, I don't have any couple moments I need to worry about. Okay, all of the B values go to 0. They don't create any moments. So all I have are the forces at AX, AY, F, and the 300. All right. So we'll start with A. The R vector will be 4K, and I'm going to cross that with AX in the I direction and AY in the J direction. All right. I'm going to do these. I'm going to kind of bring them down, and then I'll do each cross product and show them to you. So now I'll head over to the F. So to go to the F, I'm going to move 3 in the I direction, okay, and then 4 in the Z direction to get over to point C there, okay? And I'm going to cross that with that force vector that I already dealt with above. Okay, and then lastly I go to the 300, which is basically going to be half of the one I have to see. So it's going to be 1.5i plus 2k crossed with, again, that's going to be negative 3, not 330, 300 in the j direction. Okay, so now doing all of these cross products, on this one I get negative 4ay in the I direction plus 4ax in the j direction. Okay, this guy I'm going to get, what do I get? I get 600i for this cross product minus 450 in the K. Okay. And then this guy, I get negative 2.97 F in the I direction plus 1.11 F in the J direction plus 2.23 F in the K direction. So I do all of those cross products, as tedious as it might be, okay, and I get those. Now that I have those values, I can very easily write my X, Y, and Z moment equations. Okay, so I just add up all my I components, which will be minus 4ay minus 2.97f plus 600 equals 0. In my y-axis, I get 4ax plus 1.11f equals 0. Just pull out all those j components. And then with my z components, I get 2.23f minus 450 equals 0. Now I have 6 equations and 6 unknowns that I can solve for. Okay, I'm not going to do all of them. What I am going to do is show you that F I can solve with this equation right here and find that that's 202 pounds. Okay, and if you want to find out AX, AY, BX, BY, BZ, you can take this F and put it in, find AX and AY, then go up to the top equations of all your forces, figure out all your B's. But I'll let you do that on your own. So again, free body diagram. We oversimplified the reaction forces here so that we could solve it using statics methods. Okay, but once you get that, okay, I write my one force in Cartesian form. Once I have that, I can then sum the forces in the x, y, and z, set them equal to 0. I then take a moment equation in 3 dimensions, do a bunch of cross products. Once I have those, I pull out the x, y, and z components, get 3 moment equations, leaving me 6 total equations that I can solve up to 6 unknowns for.